Now let's discuss the first problem regarding dynamic programming that we will be watching, and it is called the 0-1 knapsack problem. Let me tell you the problem definition at first, and then you will know that why is it called the 0-1 knapsack. Suppose you are a thief and you have broken into a shop and you have a bag with you. You can call it a backpack or a knapsack. Both are quite the similar thing. So we will go with knapsack because it is widely known as knapsack in the problem. So you have actually a bag which is called a knapsack. But the bag has a capacity that you cannot cross. So let's say the capacity is W. If you carry more than W weight in this bag, the bag will rip apart and everything will fall down and you will get caught. So you can't carry more than weight W. And in the shop there are some really valuable items, but each item has a weight and a price. So let's see how this can look like. So let's say for an example, your bag has capacity 10 and there are multiple items in the shop, and let's say these are the price of the items and these are the weights of the items. Let's say the price is 7 and the weights are 3. The price is 10, the weight is 5, the price is 10, the weight is 5 again, and the price is 13 and the weight is, let's say, 7. Let's say these are the items that you have in the shop. Now the question is, without ripping apart your knapsack, how much profit you can make by stealing some of these items? And there is another catch, that when you take an item, you have to take it wholly. You cannot break it into half and take it with you. Let's say the first item, you break it into half so that the weight becomes half and you take it with you. It cannot happen. And that's why the problem is called 0-1 knapsack, because either you take it fully or you don't, hence 0 or 1. And now the question becomes, what is the maximum profit you can get by stealing these objects without crossing the limit of your knapsack? Now if you think about this problem, you can actually approach it in many ways. So at first let's find the answer. For this problem, if you see that you can take several combinations of these objects. You can take these two, for example, this one and this one. And the weight will be 8 if you take these two, and the profit that you will get, that is the summation of the prices that you will steal, will be 17 if you take these two. And if you take these two, you cannot take this or this because that will exceed the capacity of your bag, right? Let's think about another case where you can take this and this, but this is still the same scenario because the prices are the same. Another scenario could be if you take this and this, the middle two, and then the price that you steal will be 20 and the weight would be 10, which is still less or equal than the capacity of the bag. And there can be another combination, which is the first and the last one, these two. And if you see, in this case also the price will be 20 and the weight will be 10. And after seeing all these combinations, you surely know that there are two answers. You can either take the first and the last one, or you can take the second and the third one, and both actually adds up to 20, which is the maximum profit you can get by stealing these items. But if we change the data a little bit, let's say we can also change the price, we can also change the weights. How about I reduce the price a little of the last item? Let's say the price of the last item goes 12. Then the answer cannot be this one, that we take the first one and the last one, because then the summation of the items will be 19, but the maximum we can get is by stealing the second and the third item, and the summation of the price of the items will be 20. Now the thing is, how can you actually find out that which of the items you should steal to get the maximum profit? And that is the question of this problem. Now at first we can think of different scenarios, but we will see that these are not the correct answer. We will talk about two different scenarios at first. Let's say you want to take the most expensive item at first. That means you will take this item at first because this is the most expensive item on the shop. But as you see, if you take this item, then you can only take this item after that because the weights otherwise will exceed, and that is not the correct answer. We just showed it. The correct answer will be taking these two. So taking the most expensive one at first actually does not work. There can be another approach which will actually work for this example, but in general that actually won't work. So let me first discuss the technique, and then we will show that why this works here but in general will not work. We can actually divide the prices by the weights to find out the price versus weight ratio for each of the item. That means what is the price of each item per weight. So 3 units of weight actually costs 7 units of price. So you can see that if we do a price by weight comparison, then the first one will be 7 by 3, then the second one will be 10 by 5, third one will be 10 by 5, and the fourth one will be 12 by 7. And now that I think about it, actually in this problem this also will not work. I just noticed it, and you will see why. So the highest price divided by weights ratio will be this item, because the ratio would be slightly higher than 2, right? For this item it will be 2, for this item it will also be 2, and for this item it will be less than 2. So if you want to look for the highest price versus weight ratio, then you have to first take this item. And as you can see, that is not the correct answer, because if you take this item, then you can either take only one of these other 3 items and it will never be 20. It will always be less than 20, hence this is not the right answer. So we can see that even if you take the most expensive item at first, it actually doesn't match up. Also, if you take the highest price versus weights ratio, the item which has it, that also doesn't lead you to the actual answer. So now we have to think about what we can do to get to the actual answer.